Here are some more home building education series videos. Let's go ahead and get started with our first one. Well, welcome to part 4 in our video series on how to build this particular type of home addition. And first thing we're going to do here, in this one we're going to be working on the roof and the ceiling and the sheathing fascia board. And first thing I want to do is find the center of the building. Now I'm not in this video here, in the purpose of these video series is to provide you with different ways to build something and a few ideas in there on maybe why you might want to do that. And this one here, you can order a truss roof for it. You can build it in a few different ways. But here we're not going to use the standard method for figuring the roof rafters. We're simply going to find the center of the building and come straight up. We're going to come up here. You can use a plumb bob or a level to find the center up here at the top of the rafter. And again, this is a truss system on this house. And here we have the end truss, the gable end. And I have to point out that I have conventionally figured. I've figured the conventional roof rafters for a situation like this and been disappointed that the roof truss, let's just say I thought it was a 5 and 12, was like a 4 1/2 or a 4 3/4 and 12. So if you are working with a situation like this, you can figure the roof rafter. Just make sure you double check it. You know, you can use math to figure out the height here, or you can measure it. You can measure from here to here and use the roof rafter formulas for figuring roof rafters, or you can just simply measure it, which would involve pre-cutting the seat cut and the fascia board into the fascia board, something like this, and getting it to where the top is even. Now I am using a 2x6 because that's what the span would probably work. I don't think a 2x4 would work for this. The 2x4 for the trusses actually has some type of a support where the 2x6 isn't going to have that. But the 2x6 is running past the center of the line here. And we're going to mark the center and then cut it so that we have our first roof rafter. And then we're simply going to cut another one. We're going to use this as a pattern and cut a second roof rafter here, and then make sure that everything is working out. This rafter is going to be the main, you're going to have to make sure this one here blends in with this roof. If for some reason you were to cut this rafter and this rafter was going to need to be an inch longer or an inch shorter, you could readjust the measurements to make it work out accordingly. You could move this over a little bit, or you could just simply leave it as it is. Who's going to notice a 1/2 inch or an inch on a roof like this? And that's kind of the beauty of this system here. So you might not have the same size on each side of the roof, but it's really not going to matter for your home addition. So I need to point out that the rafter is even with the top of the framing, but it's not going to be even with the bottom. We have a 2x4 here and a 2x6 here. So to make everything blend in, we're going to go ahead and cut the rafter tail down. We're not going to cut the 2x6 rafter down, just the part that sticks over for the overhang so that everything will look nice and blend in. And pay attention, because I'm actually on this rafter here, I'm going to cut it. I'll shape it later on in the video because I don't need a double rafter here. And at the very end of the video, you'll see why. So here we have the rafters lining up, but we need to install a ridge. But before we do that, we will go ahead and move the rafters over a little bit. And we can always use some screws. Screw them into the fascia board here, and then we're going to use this to mark the fascia board. And to do that, all you need to do is grab a 2x4 and then mark it. This is going to give you a little bit of room so that you can install your roof shingles underneath this area. If you're going to be using tile, this might need to be cut a little further, but you can always do this later. But if you're not and you want this to be closer, then you'll have to figure out what that is going to be. Usually 1.5 inches or something like this works out pretty good. And then we will simply cut the fascia board and then move the rafters back so that we can now start working on deducting the rafters for the ridge. And since the ridge is going to be a 2x8, we will simply deduct 3/4 of an inch off of each one of the rafters. And you can do this before. You don't have to do it in the same order that I'm working on it here. It's just sometimes it's easier to use these rafters without the ridge cut to fix the fascia board here. So then you can install the rafters on the other side and the ridge. Now, you don't have to do this part first. If I was going to do this, I would install my ceiling joist first and then throw some plywood on top, some of the roof sheathing I'd be using. Put it on top of the ceiling joist and then start working on my roof. That way I could have an area that I could walk on. So that's just something else to consider. Again, I'm not building each one of these examples the exact same way. I'm trying to give you a couple of different methods or some different ideas of what's something that might work for you, might work a little better. So here we have the ridge and then 4 rafters cut. Do not use your pattern. Make sure that you put like I always put the number P on it or put a pattern in there. Write the word pattern on it. You do not want to install your roof rafter pattern and then realize that it's installed. You're going to have to take it back out or cut another pattern. So that advice right there is probably worth the time you spent making it this far in the video. Next up, we will install the ceiling joist. They'll be 16 inches on center. And you can see here where we have cut the one rafter here. I cut it so that I could take the block and nail it up against here. So we don't need a double rafter here, but that's not going to be a big deal. If you install it to where you have 2 rafters on the overhang, it's really not going to be a big deal. Trust me, not going to find too many people that are going to notice that. But you might need to shape the top of the ceiling joist. And to do that, you might have to have a rafter in place so that you can mark it and then use one as a pattern to cut the rest of them before installing them, obviously. Not a good idea to cut these afterwards. Better to have them cut, otherwise you're going to be walking up here. I'm not saying you can't do it that way, but if you can, cut the ceiling joist, cut the edges if they need to be cut, and then install them. 16 inches on center, like I said, 2x6. There goes our roof rafters. They are going to be 16 inches on center also, and they will connect to each one of the ceiling joist. Next up on the list, we will install the gable studs and the ceiling backing. Now I left 14 inches in between the center here so that we could put a gable vent in there. You can always have a board underneath here, a brace support board underneath the ridge if you're not going to put a gable vent in there. But a lot of times you're going to need ventilation for your ceiling in your home addition. You can always do that with a roof dormer vent also. 16 inches on center, and if you notice, I didn't have it. I had this cut off previously, but you want to have the ridge extend past to support the fascia board, and that's usually going to be 12 inches. So the distance from here to here would be 10.5 inches. Then when you put your fascia board on, the overhang would be 12 inches. But again, it's not going to be a big deal if you make that a little longer or a little shorter. And you can see here where the gable studs are lining up to make the end of the wall nice and flat. Take a look at our ceiling backing, a 2x4. Look at it from inside here. 2x4 just would nail to the gable studs. view of the corner. Now, if you notice the rafters here, I don't think the engineer is going to have a problem with this. But again, you'd have to check with your own engineer. These are just ideas. You can't take and build a house like this anywhere around the world and expect, hey, I did it from a YouTube video. No, I'm sorry. These are just examples of possible methods and, of course, things that I've done in the past. I have actually done this before in the past and had the seat cuts extending past and then nailing to the ceiling joist. Never had a problem with it. Now let's go ahead and put the blocks in and the fascia board with our lookouts. Fascia board here is going to be, we're going to cut it back. I think the fascia board came to about here, so we cut it back to here so that we could nail it into a rafter, get us some nice solid nailing. And now you can see here where the block is that I have. This rafter came and it stopped here, and I nailed the block. This gives it a nice finished look at the when we look at it from the underside after it's all completed. Everything's nice and flat here. Wanted to give you an idea of what the corner might look like, and the fascia board might need to drop down. We need to line, if you were to set a straight edge on top of the rafter, then the line would come to right here. So if you're going to be installing your fascia board, that's going to be a good idea to use some type of a straight edge to make sure that the top blends in. If this was going to be, the edge of this board was all the way to the top, it's not going to look very good. And of course the bottom, it's not uncommon to have a bottom cut like this from the angle of the fascia board when you're coming into a horizontally level fascia board, and then you have one matching the roof pitch. Now I wanted to point out that I provided you with two different examples. Here we have a lookout that is at the bottom here, and here we moved it up a little bit. And my reasoning for doing that was to give you an idea of how this could actually weaken the overhang here. I mean, if you see when we cut it here, we only have 2 inches here, where if we move it back, we're going to have a stronger part of the roof rafter here. But if we cut it here, this right here might not provide us with a nice structural or enough strength, I should say, with these 2 rafters here to create a strong enough corner on the roof. And this could actually break. If it was to break, you were using roof tile, for example, and longer overhangs. Let's just say that I had a 30-inch overhang or a 3-foot overhang, and then here I had this going out 24 inches. Something like this would definitely be a problem. If the fascia board was back about 12 inches and we had the fascia board here was even with, it was basically just 1.5 inches overhang, maybe with a 3/4 inch spacer between the fascia board and the roof rafter, then it might not be a problem. So here's one way to look at it. If I take and move the lookout up a little bit, then I got a lot stronger section of the roof there. And then the fascia board here butts in. Now, I'm not going to go into a lot of detail about finishing this, but it's not a bad idea to put some type of building paper in between. You want to make sure that it is attached to the building, to this wall here, and then nail your rafter into it in your fascia board. That way you create somewhat of a watertight area here. If you don't do that and someone comes in and they finish it, you could have some gaps in here and end up with some water leaks in the corner. Next up on the list, we will install the roof sheathing, 1/2 inch OSB, and I did this side a little different than I did this one, of course, to make some points of what your engineer might want to see. And if you remember, in one of the earlier videos, I pulled off the whole sheet of plywood. I think it went from about here over. And that's so that I could put a full sheet in here and then create a nice tie, nice structural tie between the 2 buildings. If you have a situation like this, or if I was just to use the existing sheathing and then install the new sheathing in it butt up against here, then you might need to install some type of straps over the roof sheathing with some blocks, even with the bottom of the roof sheathing, and then nail them to it to tie the building together. Another problem you could have, your building inspector might not want to see a small strip like this, so you might have to do something like this. So you're going to have a little more waste, but 24 inches would be the smallest piece here, and this of course would be larger than 24 inches. So something like this would make your engineer and your building inspector happy. So pay attention if you have a set of plans. Pay attention to this. I know a lot of people, they go in and they nail all their sheathing down. They do something like this. They put the little strip in there. Then the building inspector comes along, pulls out the plans, and then schools you on it and reads to you where you should have read this before. So make sure you read all of the information you can in the building plans, especially when it comes to this right here. Now, if you remember, I didn't install any collar ties. You can always use straps. And again, that would be something that, if it's on the plans, you might not have an option to install collar ties. The engineer might want straps. And if that's the case, the straps are going to nail over the rafters. And these ones here are spaced 32 inches on center. Yours might need to be 16 inches on center, depending upon the engineering. And here's an example of the fascia board that we cut. Here we now have a 1 inch space between here, which would probably work out fine for composition shingles. And then you would roof underneath that. So your roofing materials would go under here. Now, if you notice, I have a 1x4 here. This is going to be so that you can install some type of metal for the waterproofing. I say waterproofing. I don't like to use that word. Water resistant. It'll get a piece of metal here, and then and this will all depend. If you have a stucco wall here or siding, then you might need to cut it. This to tie it into the building on this side could actually take you a few days to do it, to complete the whole process. So this isn't going to be something you're going to be looking forward to. But there it is, your Z-bar backing, your home edition, and now it's ready for framing inspection if we got everything on the plans. And as I promised, this right here gives you an idea of what we did when we cut the rafter here so that we could install our block over it instead of having the double rafter. In this video, I will be providing you with a simple and easy math formula that you can use to figure out the gable stud height according to the spacing for them in a situation where you were going to pre-cut all of the gable studs and have them be spaced 16 inches on center, for example. And this is something we did when we worked on the tracks to speed up the assembly of the house framing. Now, for those of you who have watched a lot of my videos, I do take my time explaining stuff. I try to provide you with a clear picture of what we're actually doing. And in order to do that, I'm just simply going to start with a couple of geometric shapes in hopes of making a little bit of sense out of what we're trying to do here. So let's go ahead and start with this shape here, and then let's add the second one. Now, this one here actually has both of the long points here that we're going to be using and the 16-inch on center spacing, but it doesn't provide us with the height difference between all of the gable studs for this particular roof. So let's go ahead and use this rectangle to represent the difference in height between the gable studs, and it will also represent the difference in height of all of the rest of the gable studs. For example, if this measurement was 4 inches and this measurement here was 10 inches, then I would just simply add 4 inches on the long point side to determine the height of the next gable stud. So again, if this one was 10 inches, I'm going to add 4 inches to this one. That's going to give me 14 inches. And then I'm going to add 4 inches to the next one. which would give me an 18-inch gable stud. But we're going to need a math formula to figure out that difference, and we will get to that in a moment. I just want to make sure that everybody's on the same page here. And if you're not familiar with the home building or the house framing industry, I need to point out that the slope of the roof is usually referred to in the manner of a 4 and 12, 6 and 12, or 8 and 12 roof pitch. And what that refers to is that for every 12 inches, you're going to go up 4 inches in height on a 4 and 12 roof pitch. If this was a 6 and 12 roof pitch, this measurement would be 6 inches. It would go up 6 inches for every 12 inches. And this is usually a number that you're going to have. It's going to be referenced on the building plans. And we're going to use this to figure out the proportion of this and this. And if you look at this, where we have a 2-foot long horizontal vertical measurement, and here we have a 1-foot long horizontal measurement, then it's not too difficult that all we need to do is double the numbers on this side to provide us with a proportionate number. And that's what we're looking for when we're going to be trying to figure this out. We're going to take the proportion of this length here and this one here to figure out the differences in the height. So let's go ahead and break out our trusty calculator and get to it here. And as always, I simplified the process. I didn't want to get into cross-multiplying fractions, but there are other ways to do this. However, I think this is going to be the easiest. And in order to do it, all we need to do is multiply 16 times 4. Go ahead and do that. That gives us 64. And then we're just simply going to divide 64 by 12. And there's our number. And all we need to do with this number here is add it to each one of the gable studs in increments or in sections to get the next gable stud that would be spaced 16 inches on center. Now in the next section of the video, I am going to use the measurement 9.2 or 9 3/16. And for those of you who aren't familiar with this number, it's a number that divides into 8 foot with 5 spaces. And it's actually the reason why I'm making the video is because somebody else watched another one of my videos explaining the gable stud formula in a different way. And I will put a link here to that video. Recommend checking that out if you're interested in a easier method to deal with spacings like 16 inches on center or 24 inches on center, but not this number here. So let's go ahead and get started. 19 3/16 is basically 19.2, and we're going to do it the same way. I'm going to multiply 19.2 times 4. So I'm multiplying this number times the height, which in the math world would be cross-multiplying, by the way. And then I'm simply going to divide it by this number. Divide it by 12. And I have 6.4 or 6 3/8 inches. So if I wanted to space out my gable studs 19.2 inches, 19 3/16 inches, I would simply add 6 3/8 of an inch to each one of the gable studs, and that should space it accordingly. Now in this part of the video, I'm going to point out a problem that I ran into by converting my fractions from a decimal and rounding them up or rounding them down to where they might have been off by a 1/16 of an inch or an 1/8 of an inch, which could create problems for the length of the gable studs as you're adding the measurement to the next one. For example, if I rounded my number up from 6.4 to 6.5, figured that 6.5 inches is going to be close enough, which in most cases it will be. Like for example, if you're stuccoing the exterior of the house, this isn't going to be a big deal. If you're installing plywood siding, yes, this could be a problem. But if I'm adding an extra 1/8 of an inch because I didn't convert my decimal to a fraction correctly, and by the time I get up to 2 foot 8 inches, I'm at 2 foot 8.5 inches, that's going to create a problem for my spacing. It's no longer going to be 19.2. It's going to be a little wider. And of course, the opposite would be if I rounded down from the decimal 6.4 to maybe 6.25, then the spacing is going to be smaller in between the studs, possibly 19 inches instead of 19.2 inches. So what I would suggest would be taking the decimal that you arrive at and using that number to add all of your gable stud measurements together to find the exact length needed for all of your individual gable studs, instead of using a fraction that could be inaccurate by just the tiniest amount. Now, if you think that there are no more problems you could run into, think again, because if you cut each one of your gable studs accurately and you followed everything so far in the video, except for the fact that your wall framing plates or your roof rafter isn't perfectly straight, has a crown in it, your plates have dips in them, or they're raised up because the concrete foundation wasn't poured perfectly, then this could also affect the spacing of your gable studs. So what would I suggest? If you're going to be doing a house that doesn't require the gable studs to be spaced exactly at 4 foot for plywood siding, or 12 foot on center for other types of siding, 16 inches on center, then you might want to forget this whole formula thing and measure each one of the gable studs individually. And this is actually what I usually end up doing if I'm building a house that is not going to get stuccoed. In this video, I am going to provide you with what I believe to be the easiest way to figure a gable roof rafter. Not too difficult. But before I get started, I just want to thank everybody for all of the nice comments I have been receiving over the past few months. And I realize I make some pretty good content. It's not super awesome. If I was showing you how to do it, man, filming myself doing it, then I'd be in the top 1% of all the YouTube videos, or at least in the top 99% for sure. So now let's go ahead and get started. First thing I want to do is show you the roof rafters and the ceiling, and then the walls. And we're going to start with a slab. And I'm just going to throw some stuff out there to see if it makes sense on what I'm doing. And I've noticed that a lot of times people say, hey, your videos are too long. I got you. At least the information's in there for those of you who don't really understand, having a difficult time wrapping your mind around how to actually cut a roof rafter, or how to lay it out. And so to give you an idea with the building foundation, we can actually set the roof rafters on the foundation like this, and it would work. So the point is to cut the roof rafters before you do any wall framing. And you could always check it like this by positioning the roof rafters, pulling them tight up against the concrete slab. And again, you can always have another person help you with this, kind of throwing it out there. And your ridge, whatever the ridge thickness is going to be here, we're using a 2x10, I believe, 2x8 rafters. And if we were to lay the rafters down, something like this, then you're going to get an idea of where we're going, what we're going to be doing here. And here I'm kind of giving you an idea. When we lay out our rafters, we're going to pull the rafters down to here. So this line right here will line up with this one. But I wanted to give you an idea of some of the problems you could run into when you're trying to figure out the roof rafters, or what would be the top and what would be the bottom. So we're going to start with something like this. And then, of course, we're going to need some lines. This will be the center line of the building. We have a 20-foot wide building. The center is at 10 feet. We're going to create a 4-in-12 roof pitch. You can change this number. You can even not use the number if you don't want to. You can just lay the rafters out to the center, to some measurements, to some type of an angle that you might like on the roof rafters. But if you're going to use a 4 and 12 roof pitch, that means for every foot, the rafter is going to go up 4 inches. So no complicated roof formulas here, but you are going to need to multiply the width of the building by the height of each individual increment, which on a 4 and 12 pitch roof, every foot it's going to go up 4 inches. Every 2 foot it would be up 8 inches. So when we get to the center where it's 10 foot, the length here is going to be 40 inches. So 4 and 12, 40 inches. And of course, if we were to lay the rafters out here to where the seat cut, top of the seat cut, is even with the top of the wall framing, for example, but we're going to use this straight line here, then you can see that we're not at the top. And this is where it can get confusing to even professionals. A lot of times they think that they're starting at the framing plate, top of the framing, wall framing plates. And then that measurement is the next measurement is going to be the top of the roof ridge. That's not necessarily true. And I'm kind of going through a few extra steps here to help you figure that out. Now let's go ahead and remove the temporary ridge block there to give you an idea. So the bottom measurement here from the line to here is going to be the same as the seat cut, this line here. And if that doesn't make any sense, it should here. When I take and I change the rafter locations, I'm going to move it up a little bit. But before I do that, I just want to give you an idea of what we're working with. A center line here, 10 foot, we got a 20 foot overall width, and then 40 inches up here. So either the bottom of the roof rafter can line up with this line, or the top of the roof rafter can line up with this. We just can't line the bottom of the roof rafter up here with the top of the roof rafter up here, or vice versa. So here we have the board that we're going to use to lay out our roof rafter on. And we're going to line the bottom of it up here with this point, and then the bottom of this up here with this point here. So again, the bottom of it lined up with this corner, because this line here is kind of representing our wall framing height, our wall framing plates, but at the same time, it's just providing us with a theoretical line or a couple of lines that we would use to lay out our rafters. Then we will use these lines to lay out the roof rafter. So we're kind of going to lay out a few lines that we're going to be using to lay out the roof rafter itself. So you can actually just come straight up here off of this point and then go to the other side and come straight up here and then connect the dots here, connect these lines, and then do the same thing down here to connect the dots. And this of course would be the angle of the roof. If it was plumb, this would be a plumb line. So this would be a vertically level line. Once we flip these roof rafters up and started using them, or after we cut our seat cut. And the seat cut can be any length that you wish. If you have a 3.5 inch wide framing plate, you can always make it 3.5 inches, 3 inches, 2.5 inches, or check with your local building department to see what they want, or an engineer if you need more advice on that. So the seat cut is going to cut out of this. This is the vertically level or plumb line. This is the horizontally level line for the building. And up here we're going to need to subtract for half of the width of the ridge. We're going to be using a 2x10 for the ridge. It's going to be 1.5 inches wide. Half of 1.5 inches is 3/4 inch. We just simply come off of here with a 3/4 inch line. You know, you can make a mark here, mark at the top, and then a mark down here, and then simply draw a line across there. And there you have your roof rafter. You're going to cut the lines here like so, and then the rafter, there's no need to lay out 2 roof rafters. take this roof rafter that you lay out, cut another one exactly like it, and then flip that one over and position it on the other side. And if both of the roof rafters work out and you put your ridge block in here, then you have done a good job. And I left this up because remember, we started from this point here. So not to get confusing. And then we're going to have the same line at the top. You can see here where the line would have came up to the top. So we're a little bit lower here, but the line here, if we were just to draw a straight line, is still going to connect at this point here. Put our ridge block in there. And if there are any problems, if you lay this out, you've done all your cutting, you use this formula, and you have a couple of gaps maybe, maybe the cuts aren't real tight, then you can always adjust for that. Grab your roof rafter, make some marks, and then cut another pattern and to see if that works. And once you have a pattern, mark it as a pattern. Just write the word pattern on it, roof rafter pattern. And then after you do this, you're happy with everything, you can always start framing. But you're not going to be able to frame the building and then do this. I'm not saying you can't do it, just not going to be as easy. So use this method to figure out the roof rafters after the slab is poured or you're working on your raised floor foundation. Snap a few lines across here and hope for the best. So that's about it for this video. If you liked it, if this actually made sense, feel free to let us know in the comment area. Hit the thumbs up button. And if you do have any questions, something in here that doesn't make any sense, or better yet, if you have a better method, send me a link to a video or a web page. I'd be glad to take a look at it. And then, of course, I'll change the title to the second best method or easiest method to lay out some roof rafters without a lot of difficult math formulas to calculate.